Hey guys, so what we're going to talk about today is the second part of this lesson, which is chemistry. We're going to go over the organization of matter, chemical bonds, chemical reactions, and pH and buffers. And we'll go over some of this in the lab as well. So, what is matter? Well, matter is basically anything that has mass or weight. We kind of say that's the same thing here on Earth because of the way gravity affects it, and it takes up space. And it basically has these particles that are organized in a certain way. And these, I'm going to put in quotes, particles are what are known as elements or atoms. Atoms are, we kind of use it kind of interchangeably, the word elements and atoms. But element is a substance whose atoms all contain the same number of protons. So basically, when you're saying you have elemental oxygen, it means you have atoms of oxygen, and they're all just this typical oxygen that you're used to dealing with. They all have the same number of protons and the same number of electrons. And when you're talking about if the element is a pure substance, it can be isolated by chemical and physical means. And so when you have a combination of different elements together, and this is the most common form in which elements are found, that's what's known as a compound. And so let's look at this periodic table of elements. You don't have this in your handout. This is just something I pulled up really quick, and you can look online for one of these, right? And so these are all the different, so the way that the elements are arranged is what's known as a periodic table. And they're arranged by what's known as a atomic number. And so if you look at this very top, you'll notice that it goes from 1 to 2, then you go 3, 4, 5, 6, 7, 8, 9, 10. And basically it increases as you go across and as you go down. So if you look at this, not any element has, different elements have the same atomic number. So the atomic number determines or tells you what element you have. The atomic number is the is how many protons something has. And basically protons, neutrons, and electrons are what are known as subatomic particles. These are the individual particles that are making up an atom. Now, it does get more complicated than this, but this is about as far when we're talking about what makes up atoms. This is the farthest we're going to go. If you decide to go on and take a chemistry class, realize that some of this I'm giving you are halvesies, just enough to understand the biology that we're doing, okay? And so this right here at the top tells us how many protons we have. So this right here is the atomic symbol, and that's a shorthand on essentially what we have, and that is hydrogen, and it has 1 proton. Now that's not the only number that's on there. If you notice, the number at the bottom here is the atomic mass or weight. Now, when you have these different elements, you have a lot of different forms of them, as you'll find out here in a minute. For instance, you've probably heard of just the regular carbon that makes up organisms, and you might have heard of carbon-14, which is a radioactive form of carbon. And so when you look at all the different types of carbons that there exist in the world and you average their weight, that is what the atomic mass is. Now, you can also find out how many basically neutrons you have by using that atomic mass as well, because the atomic mass will tell you the number of protons plus the number of neutrons. So for instance, if you're looking at carbon right here, the atomic number is 6, which tells you how many protons, right? The atomic mass or weight is 12. You can round these numbers, which tells you the number of protons plus neutrons. So to find out how many neutrons you have, you would just take 12 minus 6. And that would give you the number of neutrons, which is 6. Now, there's only one thing I haven't talked about yet, and that is electrons. And there's an indirect way you can find out how many electrons you have. Everything on this periodic table is neutral. Protons are positive, neutrons are neutral, which means the only thing left is negative, which is what electrons are. So if carbon is neutral and it has 6 plus charges, then you would assume it has 6 negative charges. So the atomic number indirectly tells you how many electrons are there as well. So that's basically how you can look at each one of these. Now, as you can tell, they are subdivided based on their overall properties. You can see here that all of these guys are alkaline metals. These guys are extremely reactive. For instance, if you put a little bit of potassium, we're not talking about potassium salts, right? That you might see like what you get in a banana. But if you have elemental potassium and you put a sliver of it in water, it will explode. It's extremely reactive. You can see, so those are alkaline metals. You can see the alkaline earth here. For instance, calcium and magnesium are over here, something that you see that's very common that we need. These are all the transition metals. It's between this side to this side is how I remembered those. And these are basic metals. These in here are what are known as semi-metals. And then basically there's this big cut about here. So everything on this side you'll notice are metals. And then you have these guys, which is the yellow ones are what we're mostly concerned with. And you'll see those are non-metals. And you have one that's over here as well. And halogens are here. And if you look over here, the noble gases. And they're also called nobility because they are the most stable. They do not react with anything. Just like nobility wouldn't react with all the peasants, right? And so these are, you can basically manipulate these in a way, give them more energy, and then you get neon lights. And the different colors depends on which one of these they use because it has a different number of electrons. So that kind of gives you an overview of the periodic table. And this just gives you an increase in, basically, again, this is not on there. I just wanted to kind of have you see this up close and personal. The atomic number is here. Again, that tells you the number of protons, which are positive, right? Indirectly, electrons, which are negative. This, sometimes you'll see the name there, sometimes you won't. Depends on space. The symbol is a shorthand for whatever the name is. And the atomic weight is the protons plus neutrons, but it's really all the different types of carbon that there exist in the world, and this is their average weight. Now, in the human body, 28 of the 92 naturally occurring elements are known to be essential to life. And so 96% of all living matter contains these most common elements: carbon, oxygen, hydrogen, and nitrogen. And when we look at biomolecules later, you'll see this, right? And so the biggest one, again, is oxygen here, that's 65%. That is not just in the form of O2 in our body, but also water. Think about it, it's H2O, right? And then you have carbon, which is the backbone of most biomolecules that you'll see, hydrogen and nitrogen. Then you have less than 4% are these, mostly these type of metals that you'll find: magnesium, chlorine, sodium, potassium, sulfur, phosphorus, and calcium. Not all of them are metals, but a lot of them are. And then you'll get this 3.3% up here of others. So this kind of gives you a visual representation of the information that's in your book. Now, atoms are the smallest unit of matter. Of course, I said they're composed of subatomic particles. Protons are what charge? Oops, sorry guys. Positive. Neutrons are neutral, and electrons are negative. Now, protons and neutrons are found in the center part of the atom that's known as the nucleus, right? And you'll figure that out in cells too. And electrons are basically found in these clouds called basically sorry guys, I had a brain fart. They're basically found in these clouds. And so they don't necessarily call them, there's a difference between orbitals, which are these clouds of negative charge, and shells. And we'll talk a little bit about this so that you can figure out a little bit better. But basically you can see here the protons, this is helium, is 1 proton. How many neutrons does it have? 0. And if you look back, let me take this back for you just a little bit so you can see it. Here's helium right here. The atomic number is 1. The atomic mass is 1. So if you do 1 minus 1, right, equals 0. So there's no neutrons in the sky. Just if you wanted to see what that looks like. So you can see that here, right? So it has 1 neutron and 1 electron, right? Here you're having helium. This is on the other side, and it basically has this too. So if you look here, you can see in here you have 2 protons, 2 neutrons, and 2 electrons, right? And so let's talk really quick about how this works. First, I want you to go and tell me how many neutrons carbon has. Actually, let's do something different. We just did carbon. Let's do oxygen here really quick, okay? And let's just take these out. So let me go back to our really quick, our periodic table for you to do that. So first you have to find out how many protons does oxygen have. So oxygen is right here if you can see it. So there are 8 protons. So that's the atomic number is 8, right? So that gives us 8 protons. What's the atomic mass? Is 15.999, so you can round it to 16, right? So how many neutrons do you have? You can figure out 16 minus 8, right, equals 8. And then how many electrons does it have? Well, it has 8 protons, so it has 8 electrons. So hopefully you figured out how to use that. Now, isotopes. These are different kinds of atoms. They have the same number of protons, but they have a different number of neutrons. And so because of that, the nucleus can vary sometimes and they can become radioactive. So for instance, here is showing you a hydrogen atom, a normal one, right? And so on here, they're showing the nucleus. It has a proton of 1 and an electron of 1. And neutron equals 0, right? There are cases that if you look at this, he looks different, right? This would have, what would the atomic number for this isotope of hydrogen be? Atomic number. Well, as long as you have hydrogen, the atomic number never changes, right? So it's still 1, which means how many protons it has? Still 1. But what do you notice here? It actually has a neutron here. So what would change would be the atomic mass. The atomic mass would now be 2, which means the total number of neutrons you'd have are 1. And your electron would still remain the same. Now, because this is trying to become more stable, the excess energy it has because of that neutron, it will slowly decay and release till it ends up becoming him, which is why it becomes radioactive. Now, isotopes are used in medicine. It allows them, because of this radioactivity and energy it releases, it allows it to be able to detect some illnesses. So they use radioactive glucose a lot of times to look and identify cancer, because glucose gets taken up more in cancer cells. So if they have a bunch of you drink this radioactive glucose and it comes to an area that shouldn't have a large number of basically cells that are needing glucose, then they know that there's a chance there may be cancer and they can take a biopsy. They also use radioactive iodine because iodine goes into your thyroid, and they can look at the size by taking radioactive images, right? And you might notice more carbon-14, which is used for radioactive dating, right? Carbon dating. So those are all examples of isotopes. And those happen because the number of neutrons are different. So look at this guy and determine which atom is an isotope. Now I can give you a hint. The very first thing you want to look at is identify what type of atom this is. And how do you identify the atom? By looking at the atomic number. So the atomic number tells us how many protons, right? So you look here and you see there's 8 protons, which tells you this is what? Oxygen. And then from there you figure out, okay, well, how many neutrons do I have? Well, you need to look at the atomic mass, which is, we know, 16. And then you find out that the number of neutrons you should have is 8. Well, this looks good. This is more. And so then you know that this is an isotope. Now, the next thing that we can go on here is we've looked at protons. That tells us what our element is. We've looked at neutrons. That tells us if we have an isotope or not. The next thing we're going to look at are electrons, because electrons are important in determining the chemical reactivity of something and bonding. And for instance here, you can look to see, do I have the right number of electrons here? Well, we have 1, 2, 3, 4, 5, 6, 7, 8. Yep, it's neutral, right? If you had 9, you'd have 1 more, so it would be a negative. If you had 7, you'd have 1 less, so it would be positive. And so that would determine its chemical reactivity in some ways, right? Or it would tell you what we're about to talk about. If you have too many, too less, things like ions, anions, cations, all of that. But the electrons determine reactivity. So let's go into that. So chemical bonds. How do we make chemical bonds? Well, chemical bonds are basically energy relationships between 2 electrons of reacting atoms. So we're basically asking ourselves how electrons from each atom will react to each other, or will they want to hang out and basically share their areas? Or will some atoms grab electrons from one or give electrons away to the other atom? So how they interact or what they do with their electrons between 2 atoms determines bonding. Now the reacting atoms, what reacts between the 2 atoms? And there are their electrons, but there are their electrons in what's known as a valence shell. The valence shell is the outermost shell. So we're going to talk about this because earlier we were talking about orbitals. And orbitals are those areas that you find electrons. Shells have to do with energy. So electrons that are in valence shells that are chemically reactive, which means they're not stable, they are going to make bonds. And they're basically bonds have 2 rules. Atoms that have only 2 electrons in the first shell will react to fill the first shell. And atoms that have electrons in more than 1 shell react to fill the outermost shell. And this is generally the octet rule. Now, we're not always going to do the octet rule, but for sakes of purposes, we are today, right? So what I'm going to do now is I'm going to take a bit of a break, allow you a breather, and then when we come back, we are going to talk about electrons.